Remember here, always f of x is greater than or equal to g of x in the interval a comma b. If x is equal to 0, y is also 0. If x is equal to 1, y is also 1. So therefore, the point of intersection of the two curves is 0, 0 and 1, 1. Lower limit is 0 and the upper limit or the maximum end of the interval is from 0 to 4. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in our previous sessions, we have learned how to find the area under the curve whenever a curve under straight line is given. Now here we are going to study about the area using the method of integration between any two curves. Now consider here two curves where I have taken a curve y is equal to f of x and a curve y is equal to g of x. We have to take a curve between these two, that is the area bounded by these two regions. So what I am supposed to do, first here I will find the area under the curve f of x. Then I can find the area under the g of x. So if I subtract this area from the f of x, then I will find the area between the region bounded by f of x and g of x. So that is why here, let the two curves y is equal to f of x and g of x given as shown in the figure, and the intervals are from x is equal to a to x is equal to b. Then the region is given by f of x minus g of x. And again, using the same method of finding the area of rectangle, that is a very tiny rectangles, we can combine them, that is integrate them from interval a to b so that we can find the area individually. Remember here, always f of x is greater than or equal to g of x in the interval a comma b. Now suppose we have a curve like this. So let me take this curve here. So this is our f of x and this is one more curve g of x. So in previous curve we have taken only this is the part which we have taken. So clearly you can see f of x is greater than g of x. So here f of x is greater than g of x. And when the curve goes down and here when the curve goes up, then here g of x is greater than f of x. So therefore, here we have three intersection points between the curves. So I will divide the interval or I will find the total area by integrating the area from A to C and area from C to B. And we know that since the area between the curve is written in the form of f of x minus g of x, for the first interval, we will take integral from a to c, f of x minus g of x dx. And for the second curve, we will take integral from c to b, g of x minus f of x, because g of x is greater than f of x. So using this method and dividing the interval, we can find the total area bounded by this region. So let us take the problems now. Find the area of the region bounded by the two parabolas y square is equal to x and x square is equal to y. So y square is equal to x is clearly a right-handed parabola and x square is equal to y is a upper parabola. So clearly when they intersect, the blue shaded region here indicates the area bounded by the two curves. So now we need to apply the interval and by the method of integration we are going to find the area bounded by this region. So here we have two equations, y square is equal to x and we have x square is equal to y. So if I substitute y is equal to x square here, then it becomes x power 4 is equal to x, or I will get x power 4 minus x is equal to 0. If I take x as a common factor, then I will get x cube minus 1 is equal to 0. So from these equation, I will get x is equal to 0 and x is equal to 1. So that means at the point x is equal to 0 and at the point x is equal to 1, we have a point of intersection. If x is equal to 0, y is also 0. If x is equal to 1, y is also 1. So therefore, the point of intersection of the two curves is 0, 0 and 1, 1. So therefore, here area can be taken as integral from 0 to 1. So f of x minus g of x. So I can take f of x as y square is equal to x. So this one I can take it as f of x and this one I can take it as g of x. We know that f of x must be in terms of y only. Here I have y square. So if I need y, then it is root x. So therefore root x minus g of x is y here, which is x square. So this is x square into dx. Now let us integrate here. So again root x becomes x to the power 3 by 2 by 3 by 2 minus integration of x square is x to the power 3 divided by 3 and the limits are from 0 to 1. So here you can apply the limit as 1. So you will get 1 to the power 3 by 2 is always 1. This you will get it as 2 by 3 minus 1 by 3. This is your upper limit and minus lower limit is completely 0. So therefore your answer is 1 by 3 square units. So this is the area bounded by these two curves. Next, find the area lying above x-axis and included between the circle x square plus y square is equal to 8x and inside the parabola y square is equal to 4x. So here I have taken a parabola y square is equal to 4x. So this is a parabola, that's a right-handed parabola, and we have a circle x square plus y square is equal to 8x where 8x is r square. Now we have the region above the x-axis bounded by the circle as well as the curve inside the parabola. Clearly they have said you the area lying above x-axis and included between the circle and the parabola. So between the circle and the parabola means this is the shaded region which represents the area bounded by this curve. So now here let us take the equations and find the point of intersections of the two curves. So we have this and y square is equal to 4x. So using y square is equal to 4x, we will get x square is equal to 4x. So again x square minus 4x is equal to 0. So we will get x is equal to 0 and x is equal to 4. X is equal to 0 and x is equal to 4. So here is the point of intersection of the circle as well as the parabola. Now clearly you can see from 0 to 4 you have only this region. So what about the remaining region? It is also between the curve as well as parabola and clearly you can see here the distance is 8 times. So therefore here this is 8, 0 and here this region varies from 4 to 8. So therefore here I have to take the sum of two regions. So therefore total area is here. So this is the region bounded by the parabola. So therefore here the integral is from 0 to 4. And what is parabola? We have y square is equal to 4x. But if I need y, it is 2 root x with respect to dx plus again this region from 4 to 8 and this is the region bounded by the circle, only the circle here. So therefore here we have y square is equal to 8x. So therefore y becomes here square root of 8x minus x square with respect to dx. Now here I can apply the integration easily, but here let us convert this into the standard form of the integral. So now here I can write 2 0 to 4 root x dx. Now square root of 8x minus x square can be written as 4 square minus x minus 4 whole square. So by using the completing square method. So here the integral is from 4 to 8 square root of 4 square minus x minus 4 whole square with respect to dx. Now here root x we have 2 into x to the power 3 by 2, 3 by 2, and the limits are from 0 to 4. So here this is in the form of square root of a square minus x square, which is x by a root of a square minus x square plus sine inverse x by a. Now using the standard formula of a square minus x square, we can write this as x by 2, which is nothing but here it is x minus 4 by 2, square root of a square minus x square, in the sense it is 8x minus x square, plus a square by 2, that is 4 square by 2, sine inverse x by a, which is x minus 4 by 4. And the limits are from 4 to 8 here. So now let us apply here 3 by 2. When it comes here, it becomes 4 divided by 3. 4 to the power 3 by 2 minus 0, it becomes plus. Apply the first upper limit here. 8 minus 4 by 2 is, you will get it as, so 8 minus 4 is 4, 4 by 2 is 2. Next here 8 8s are 64, 8 square is 64, 64 minus 64 is 0. So 0, it is 2 into 0, plus 4 square by 2 is 16 by 2, which is 8, and 8 minus 4 is 4, 4 by 4 1, sine inverse of 1 is pi by 2. So this is your upper limit, minus lower limit. 4 minus 4 is 0, 0 into anything is 0. Again 4 minus 4, 0 by 4 is also 0, sine inverse 0 is also 0. So 4 cube is 64, square root of 64 is 8, so it is again 4 by 3, 8. Plus here 2 1s are 2 4s are, so we get it as 4 pi. So on multiplying this, you will get it as 32 by 3 plus 4 pi square units. So this is the required area. Next we have, find the area of the region enclosed between the two circles x square plus y square is equal to 4 and x minus 2 whole square plus y square is equal to 4. So observe here we have y square is equal to y square is equal to 4. So we can equate x square is equal to x minus 2 whole square. So we will get x is equal to 1. So both the curve have the intersections at 1. So if you put 1 in any one of the equation, you will get y is equal to root 3. So therefore, the point of intersections you can clearly say 0, 0, 1, root 3, and clearly for the second circle here you have 4. That means the radius is 2. So this distance is the radius of the one circle, which is also the distance between the area, and here again it meets at 1, minus root 3. Now we need to find out the area enclosed by the two curves. So here first I will take only the upside, that is the positive x-axis. So if you calculate the area from 0 to 1, then you can calculate the area from 1 to 2. Then add it twice, so you will get the total area below the x-axis also. So therefore here total area is 2 times. So for the first circle it is from 0 to 1 and the area is here. This is the area bounded by this region, and this circle is x minus 2 whole square plus y square is equal to 4. That is, when it converted in terms of y, it is 4 minus x minus 2 whole square under the square root with respect to dx plus, and so the region here, this is the second region which is bounded by the circle x square plus y square is equal to 4. So therefore, and this is integral from 1 to 2, under the square root you have 4 minus x square with respect to dx. So this is 2 times the area. So this region represents the region above the x-axis, and if you multiply 2, it gives the total area bounded by this region. Now again here we have 2 times. Let us apply the standard integral. This is of the form a square minus x square. Value of a is 2. So now x by 2 square root of this is 4 minus x minus 2 whole square plus a square is 4 by 2 sine inverse x by a, that is x minus 2 by 2. So this is the limit from 0 to 1. Next again plus we have, so here x by 2 square root of 4 minus x square plus a square is 4 by 2 sine inverse x is by 2 with the limits 1 to 2. Now here you have 1 and for 0 the complete equation becomes 0 here. Now let us apply the limit for this. So we have area is 2 times. So here if you substitute 1, 1 minus 2 is minus 1 by 2. 1 minus 2 is minus 1 whole square. So which becomes 1. So root of 4 minus 1 is root 3. So the first one is minus half root 3. Next we have again 4 by 2, 2. So sine inverse of minus half can be taken as minus sine inverse half. So which becomes plus 2 minus pi by 6. So this is for the first limit. Now for the second equation we have 2 as well as 1. So if you put 2, this becomes 0. Now here you have 2 sine inverse 2 by 2 is, you will get 2 into pi by 2. So plus here we have 2 into pi by 2. Next we will substitute for 1 here again. So now let us substitute here. So here it is 2 times. So let's see what happens for the upper limit here. Upper limit is 1. 1 minus 2 we have minus half. So minus 1 whole square is 1. So we have root 3. Next we have 1. So 4 by 2 is 2. Sine inverse of minus half can be taken as minus pi by 6. So this is for the first limit. Next we have minus. If you put 0 here, 0 minus 2, so which becomes minus 1. And minus 1 here again 0. So 0 minus 2 is plus 2. So the first term becomes 0. So this can be completely written as 0 here. And the second term here is plus. So we have 2. Sine inverse of minus 1 can be taken as minus pi by 2. So here we get. And for the second term we have here. So 2 by 2 is 1. 2 square it becomes 0. 4 by 2 is 2. Now sine inverse 2 by 2 is pi by 2. Next minus we have 1 here. So 1 by 2 and 4 minus 1 becomes root 3 and plus 2 here. Sine inverse half is pi by 6. So this is another thing. So on solving this completely, so we have 2 minus root 3 by 2. So we have 8 pi by 3 minus 2 root 3 square units. So this is the area obtained after the simplification of this. So once you multiply 2 here, many terms cancels this here. So you have minus root 3 2 times plus 2 pi minus 2 pi get cancels here. Next you will get 2 pi by 3. So and 2 pi by 3. So you will get, you are going to add it. So you will get the value as 8 pi by 3 minus 2 root 3 square units. Using integration, find the area of the region bounded by the triangle whose vertices are 1, 0, 2, 2 and 3, 1. So we need the equation in the form of y. So therefore we need to form an equation of lines here. So first let us see the equation of AB. So equation of AB. So we know that we have an equation y minus y naught is equal to, so y2 minus y1 x2 minus x1 into x minus x naught, or we can take this as naught. This is y1, y1. So we have an equation that is y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. So which is the general equation to find the equation of a straight line. Now by substituting this here we can have, so consider here AB. So we have y minus 0. And y2 minus y1 is 2 minus 0, which is 2, divided by x2 minus x1 is 1. And here we have x minus 1. So we get the equation as y is equal to 2x minus 2. Now let's see equation BC for BC. So we have here BC. So let's take y minus, what is y1 there? We can take it as 2. Next, y2 minus y1 is minus 1. x2 minus x1 is 1. Again we have x minus 2. So here we can get y is equal to, so we have minus x, minus into minus plus 2 and plus 2. We can get y is equal to minus x plus 4, or we can write y is equal to 4 minus x. Now let's see for equation of AC. So if you take equation of AC, so that is y minus 0 is equal to y2 minus y1 is 1 and x2 minus x1 is 2 divided by x minus 1. So from this you can get 2y is equal to x minus 1, or you can take y is equal to x by 2 minus 1 by 2. Now clearly you can see the area. The first interval goes from 1 to 2, 2 to 3 here. So from 1 to 2 you have a area bounded by the line AB. So this is the region bounded by AB. Next you have from 2 to 3. So this is the region bounded by BC line, and AC is the region from 1 to 3 which you have to subtract. So therefore I need to take the sum of equation containing AB plus equation containing BC and then subtract the equation containing AC. So therefore my total area is, so first I will take integral from 1 to 2. So what is the equation of this line AB? 2x minus 2 with respect to dx plus equation containing the line BC, that is integral from 2 to 3, I can take it as 4 minus x dx. So this one I have to subtract with the line containing AC 1 to 3, whose equation is x by 2 minus half with respect to dx. So now area here it becomes 2x square by 2 minus 2x. 1 to 2 is the limit. Next here I have 4x minus x square by 2. Limits are from 2 to 3 minus. So here I have x which becomes x square by 4 minus 1 by 2x, and the limits are from 1 to 3. Now let us cancel this. So area x square is 2 square, 2 square is 4, again 4. So it is 0 for the upper limit. Minus, if you take 1, 1 minus 2 becomes plus 1. So 0 plus 1 for the first equation. Next we will go for the second equation. 4 3s are 12 minus 3 square is 9 by 2. Next we will take minus 2 4s are 8. Minus into minus plus 2 square is 4. 4 by 2 is 2. So this is the equation for the second one. Next we have minus 3 square is 9 by 4. And here we have minus 3 by 2. Again we have minus of 1 by 4 plus 1 by 2. So on solving this numericals, we will get the total area as 3 by 2 square units. This is the region bounded by the triangle ABC. So first you will take the region from A to B, that is from 1 to 2, plus region below the curve BC, that is from 2 to C. Then you will subtract the region below the curve AC. Then only you will get the total area bounded by the triangle. Next, using integration, find the area of the triangular region whose sides having the equation y is equal to 2x plus 1, y is equal to 3x plus 1 and x is equal to 4. So clearly I have drawn a straight line using the coordinate x and y axis. So here you can see the intersection point of all the three vertices, that is a 0, 1, b 4, 9 and c 4, 13, and x is equal to 4. So this is the line x is equal to 4, which is a parallel to y axis or perpendicular to x axis, and this is the maximum point you can see. So 4 is the last interval, that is the end of the interval. So clearly from the figure you can see the area bounded by the line AC is below the curve. So that curve has to be subtracted by the area bounded by AB. Then only we will get the region bounded by this triangle. So, and x is equal to 4 is just a line, so no need to write any equations for that. And the interval is from 0 to 4. So therefore required area is interval from 0 to 4. I have to take this curve y is equal to 3x plus 1 and subtract the area bounded by this region. What is this region? Area under the curve 2x plus 1. So 2x plus 1 with respect to dx. The limits are same because the lower limit is 0 and the upper limit or the maximum end of the interval is from 0 to 4. So therefore here after applying it, it is 0 to 4. 3x minus 2x is x here. Plus 1 minus 1 get cancels. So it is dx. So x square by 2 is the required integral. So 0 to 4 is the limit, and when you apply it, it is 4 square by 2, 8 minus 0. So which is equal to 8 square units. So this is the area bounded by the lines or bounded by this lines formed a triangle. So this is all the chapter applications of integrals. We'll meet you in the next session with the new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.